Dr. Liu. So here we have a live video on the top left corner, some wiring instruction on the bottom left, and also we have MicroPython running on the ESP32 board. This will be similar if you're running something else such as the Arduino IDE. So the goal of this video is to show you that this board, this SK16 adapter board, can be used with a UART connection such as the one present on ESP32 boards. Um, the board was originally designed to only work with USB, but I can also make some modifications, and depending on needs, I might actually just print out boards that are specifically for UART. So let's see what's the update. I made some changes on the back side of the board and some on the front side, but you won't be able to see that even with this video detail. So all you're seeing are the connections on this row of 8 pins. So I've used these 4 connections. So on the board, the adapter board, there are these markings plus minus. That would be the first couple of pins here. The first one being plus, second one being minus. And the plus should be connected to the ESP32 board's 5-volt pin or the USB power pin. So that supplies the power to the adapter. And then ground pin is connected between the two boards. And then there are 2 more pins on this row that says D and C. So skip those. Those are I square C connections. And then you'll be at the 3 and the 4. The 3 pin is supposed to connect to your ESP32's TX. So your ESP32 is sending information into the adapter on pin 3. And then 4 is supposed to be the RX on your ESP32. So your ESP32 is receiving on pin 4. I already have a level shifter that I put on the backside of the board that gets you the proper voltage for the 3.3 volt board so it won't get damaged. And here is a set of 8 connectors that can connect to these wire harnesses or adapters for the TRS or a tip ring and sleeve stereo plug. So I have this one hooked up. Make sure you have this hooked up correctly based on the markings on the board. Minus S plus, that would be negative signal and positive. So on my wire, the negative is black and the signal is white, and positive is red. Just make sure do not swap the two. And I have an old Decagon 5TM soil temperature and moisture sensor. If you knew Decagon before, good for you. You've been working on these sensors for long enough. Otherwise, they're now known as meters group. They might still manufacture these, probably under a different part name now. So anyway, this is how it's hooked up with the wiring, and I'm going to run this program. So let's just see how it works. Let's see, click, and here we're waiting for this thing to run. Okay, it has a few delays just to make sure the board starts up. So the first line is probing the adapter itself. It's supposed to respond with this. The adapter itself is on the address lowercase z, and it says it conforms to 1.3 version of the SDI 12 standard. And the manufacturer or vendor name is me, Dr. Liu, and the device is SDI translator and a version number of 1.5B. B would be what 11 in hex, and backslash R backslash N, that's just a new line. And then later it also sends out this other command. The first command was actually the ZI exclamation sign. So asking the Z sensor, what is your information? So that was the response right here. And then later it sends out this question mark exclamation mark. That means if there is a single sensor, such as this 5TM sensor, is asking that single sensor to furbish its own address. So here we have the 1 backslash R backslash N. This means it's at address 1. It didn't really get identified because I didn't say 1I exclamation mark. I would use the question just to see what sensor address is currently at. Since this is MicroPython, I can pretty much keep working on this, such as UART, right? I'll ask for the information on this sensor that starts with the B, with binary, or byte sequences, binaries. So this is one I exclamation mark. So that asks the sensor for its identification string. So 3 bytes sent, and then I can read. So UART read line. Okay, so that is that. So address 1, conforming to standard version 1.3, the old company name Dakigang, model number 5DM, and I don't believe 387 is actually a serial number. I've had plenty of these, and they don't identify themselves as having unique serial numbers, and I don't have it on mine either. But this is probably just a kind of a model firmware number. There's no serial number in front. So that means you are able to communicate with it. If you want to read data from it, you can do uh, UART write. Again, I'm just typing up the skeletal structure, and you'll just say 1 M. So that tells the sensor to measure. And let's read this. Okay, so what this says is the sensor says I'm address 1. I'll take a 1 second, and I'll respond with 2 data points or 2 values. And if you read again, there's actually another response. The response means the sensor has already completed the measurement. That was actually within 1 second. We were talking, so it's already there in the buffer. I just read it out. So that's the whole sequence. You ask to make measurement, and it says, okay, I will give you 2 data points, 2 values in 1 second. And wait a second, already I'm done. Okay, so that's what the sequence is. So now you're supposed to issue the retrieve data. So again, skeletal structure, the 1D0 exclamation. So send this out, 4 bytes sent, and then you can read it back. All right. So address 1, um, values, positive values will carry explicit positive signs. So 1.33 and then 25.0. The 25.0 is temperature in Celsius. That's my room temperature. And the 1.33 is a measurement. You have to understand it by reading the spec sheet. So this tells you, okay, it's done its measurement. And in your program, you would try to replicate a similar sequence. I would probably try to identify the adapter, but that only takes maybe just before going into data acquisition loop, just do it one time so you know the adapter is responding. And then you may or may not have to do the question mark, exclamation mark, because you already know the addresses of your sensors. So then all that's left to do in your loop is you loop through commands like this: one measurement exclamation, and then you read back the response. And also this is called service request. That means it's done ahead of time. And um, and then you issue the data extraction command. If there are more data, it cannot return in one line. You have to keep doing this with 1D1, 1D2. So let's try 1D1. It's already done returning all the data. So if you just issue this one once again, read back what it responds, it only gives you a 1 and says, okay, I'm done. I'm here, but there's no more to return, right? So you keep doing the 1D0, D1, D2, and so on until you have gotten all the data that it promised to give you, such as this 2 different values. Okay, so that should be done with one sensor, and then you go down to the next address that has a sensor, do the 1M, and different sensors companies have different measurement commands. The M is the default command. There could be a series of M1s, M2s, M3s that are responding to different measurements or measurements returning different units, right? So these have to be looked up in the instruction manual, and you'll be able to explore that on your own. Hopefully, this get you started. Thanks.